In a bold declaration, scientists have declared that they had located a celestial body distinct from any formerly known. NASA, renowned for its groundbreaking revelations, has revealed that this planet is not only captivating because of its dimensions and location, but also because of the light it emits that seems to be synthetic. Could we be on the verge of unveiling concealed realities that might profoundly improve our comprehension of the universe? Could this finding suggest the possibility of life existing on other planets? By investigating NASA's groundbreaking discoveries, we will soon uncover the facts behind this remarkable occurrence. In 2007, NASA initiated the Dawn mission with the objective of investigating some of the most intriguing entities within our solar system. Equipped with 3 propulsion systems, Dawn began its journey with a 14-month investigation of Vesta, the second largest asteroid in the asteroid belt. It sent back exceptionally detailed images and data that shed light on Vesta's intricate surface features and diverse geological past. Upon completing its mission at Vesta, Dawn moved on to the next phase of its voyage, one that was likely even more exhilarating: a thorough examination of the dwarf planet Ceres. Thanks to its ion propulsion systems, Dawn was able to escape Vesta's sphere of influence and head towards Ceres, a feat that would have been unattainable with traditional chemical propulsion methods. These propulsion systems provided consistent thrust, enabling Dawn to traverse vast distances and create a stable orbit around Ceres. Discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt, situated between Mars and Jupiter. For years, it was classified as the smallest dwarf planet in our solar system until its reclassification in 2006. With a diameter of approximately 950 kilometers, Ceres is the largest and most massive body in the asteroid belt, one of the most captivating due to its unique characteristics. Scientists eagerly anticipated the first close-up images of this mysterious planet, which revealed brilliant spots scattered over its surface, especially in a large crater known as a crater. These luminous spots ignited immediate curiosity and speculation within the scientific community. Prior to the Dawn mission, the best images of Ceres were blurry, low-resolution photographs taken by the Hubble Space Telescope. Very little was known about this dwarf planet, and the promise of in-depth evaluations from Dawn fueled excitement among astronomers and space enthusiasts alike. The Dawn mission aimed to enhance our comprehension of planet and star formation and investigate the role of water in the development of planetary bodies. The bright spots on Ceres, also discovered on other asteroids, could be composed of materials with high reflectivity, possibly residual salts from evaporated water. This discovery hinted at the possibility of cryovolcanism, volcanic activity that erupts water or brine instead of molten rock. But what exactly are these enigmatic lights, and what do they reveal about the true nature of Ceres? Could they be signs of ongoing geological processes, or something even more extraordinary? Ceres distinguishes itself from other items in the asteroid belt due to its size, mass, composition, and the potential presence of ice and water. As opposed to typical rocky asteroids, Ceres has a more comet-like composition, suggesting it could unveil more secrets about the early solar system. After 2 years in transit, the Dawn spacecraft finally began its approach to Ceres in early 2015, marking a significant milestone as it was ready to provide the initial comprehensive views of the largest body in the asteroid belt. As Dawn approached, the images got sharper over time, revealing a world previously hidden from view. The initial photographs showed a cratered surface, suggesting a long history of impacts. However, what drew the most attention were the mysterious bright spots amid the dark, rugged terrain. As the resolution of the images improved, scientists began to formulate theories regarding these locations' nature. Were they areas of ice reflecting sunlight, or perhaps even something else more remarkable? Speculation ranged from mineral deposits to possible signs of cryovolcanic activity. To everyone's astonishment, closer examination showed that the brightest spot wasn't just one feature, but a collection of distinct areas. The most widely accepted explanation was that these were salt deposits left behind after water sublimated. This suggested that Ceres had, or may still have, some kind of geological activity, with the potential to push water or brine to the surface, where it evaporates quickly, leaving behind bright, reflective residues. These findings challenged previous perspectives on Ceres, painting a picture of a more dynamic and intricate world than anyone had imagined. The potential existence of subsurface water or brine pockets could have profound implications for our understanding of the possibility of life elsewhere in the solar system. Ceres is often described as an icy world. Unlike most asteroids, which are largely composed of rock and metal, its surface is porous and rocky. Ceres stands out for its distinct structure. The surface is a blend of water ice and hydrated minerals, including clays and carbonates, giving a less dense structure than its rocky neighbors. This composition suggests that Ceres may harbor significant amounts of water, both beneath and on its surface. The upper layer is rocky but porous, with trapped ice and various volatiles that make it resemble a comet more than a typical asteroid. It is believed that Ceres has a distinct internal structure made up of a rocky mantle and a core rich in water ice, which makes up about half of the planet's total volume. Ceres' mantle is likely a mixture of rock and brine surrounding a denser core, possibly made. The presence of significant silicates and ice made of water raises the possibility that Ceres may have once supported liquid water, particularly when the core was heated by radioactive decay. Throughout its early years, this internal composition sets Ceres apart from its asteroid neighbors and opens up fascinating questions regarding the possibility of geological activity and the role that water plays in shaping development. But that is only one aspect. The identification of ammonia-rich clays on Ceres indicates that this dwarf planet might have originated in the colder outer zones of the solar system before migrating inward. The presence of ammonia could lower the freezing point of water, allowing briny liquids to exist on or near the surface. Insights into the structure of Ceres and its past not only expand our knowledge of this enthralling dwarf world, but also offer crucial clues about the mechanisms driving the formation and transformation of icy celestial bodies throughout the solar system, the future of space travel, and what comes next. Cryovolcanism is a fascinating and relatively uncommon geological phenomenon, especially in contrast to more familiar volcanic activity on Earth. Rather than spewing molten lava, cryovolcanoes, or ice volcanoes, eject substances such as water, ammonia, or methane. These compounds can remain in the form of a gas or liquid in extremely frigid environments. On Ceres, cryovolcanic activity allows salty water to ascend to the surface. Once this briny mixture encounters a vacuum of space, it swiftly undergoes sublimation, directly changing from solid or liquid into gas, and what's left are residues of reflective salt. These appear as the enigmatic bright spots observed on the planet. The most prominent of these bright areas is located in a Keter crater, specifically a region nicknamed Spot 5. This site has drawn considerable attention due to its extreme reflectivity and observed temporal variations. These shifts are believed to be linked to water sublimating, suggesting that cryovolcanism may still be active or occurred recently. In addition to Spot 5, Ceres includes numerous other luminous spots, each exhibiting unique traits. These are not restricted to a single area but are dispersed across the surface of the planet, indicating that cryovolcanic phenomena may be widespread. This underscores Ceres' vitality and contradicts earlier assumptions that it was a still, dormant body. The Dawn mission carried on, transmitting increasingly detailed images. It revealed a surface peppered with craters, each narrating a chapter of the planet's story. From scientists' insights and theories about this new world, these revelations have fundamentally changed how we perceive Ceres. With its icy makeup and signs of potential cryovolcanic processes, the planet now stands as a dynamic and evolving entity, no longer merely a frozen relic. The brilliant spots, particularly those in the Keter crater, continue to stir scientific interest. They may represent not only geological activity, but also processes that suggest Ceres' capacity to sustain subsurface water. Studying Ceres provides broader implications than just learning about a single dwarf planet. By analyzing its internal layout and surface, including bright deposits and anomalies, scientists can derive insights into behavior and evolution of other icy bodies within our system. The substances found on Ceres, such as water ice, ammonia-rich clays, and reflective salts, may shed light on the chemical compositions and environmental dynamics of similar planetary objects. Moreover, the possibility of cryovolcanism opens enthralling new paths, not only for comprehending geological activity on dwarf planets and icy moons in our solar system, but also in the faraway exoplanets. This suggests that regions we once thought to be dead and uninhabitable might, in fact, support complex natural processes. It could indicate that distant planets once dismissed as frozen and barren might hold the conditions necessary for life. Final reflections on NASA's Dawn mission. What it means for humanity. NASA's Dawn initiative remains a shining example of the potential of cosmic exploration. The information it delivered has already changed the perspectives of science on the development and evolution of our solar neighborhood. As we delve further into the enigma surrounding Ceres and similar remote entities, each piece of evidence facilitates our larger narrative of how planets, moons, and other celestial formations evolve. Currently, the bright areas on Ceres stand among the most fascinating puzzles of planetary science. But they represent just the beginning. As innovations in technology continue and newer missions are deployed, the chance for even more groundbreaking discoveries increases. Ceres, once an overlooked speck in the asteroid belt, now emerges as a symbol of intrigue and promise. Its terrain, layered interior, and cryptic shining spots might unlock the keys to comprehending our solar system's youth and the mechanisms that forge its planets. The potential for microbial life, or at least the ingredients necessary for life to exist, on Ceres remains an exhilarating notion that continues to energize researchers and space aficionados alike. As our journey of exploring distant frontiers moves forward, the lines that separate reality and imagination continue to blur. What was previously restricted to science fiction, the prospect of extraterrestrial life, has become a genuine scientific pursuit. Whether or not microscopic organisms thrive in Ceres' hidden reservoirs, the conditions found on other icy celestial bodies may prove hospitable to life forms either known to us or still unimagined. These are the mysteries that will inspire the next era of space investigation, and perhaps reveal deeper, universe-wide truths.